This conference will now be recorded.
Okay, I'm going to make Jay the presenter.
I got it. All right, thank you, Shen. Hi, everybody. Hope your new year has started well. Uh, you had a good time on the new year. So let's get started here. So the agenda for this meeting is, and onwards for a few of the meeting is uh, the 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 INT APIs, the IOM and IFA APIs, which were earlier deleted. And I had time, so I used the time to get those things cleaned up and committed them just for folks to take a look. So we will start discussion on that. And offline, myself and Mickey had one discussion. We didn't got time to have more discussion. There was only one discussion, and we started with some brainstorming. So Mickey has put something as well. And then some point of time, I'll give the baton to Mickey to put his thoughts across. So with that background, let me just do a quick review of what we talked about the INT API proposal in the last meeting. So, if you recall, we were talking about uh, two technologies. One is the IOM, actually three of them, two which are being moved into the IETF community, and one which is being talked about in the P4 community. And I thought that all these things globally can be called as the INT technologies, and internally they are referred as different. So in this API proposal, the top level hierarchy is going to look like INT. And within that, then we talk about the IOM set of attributes, the IFA set of attributes, and IFA has two flavors, 1.0 and 2.0. And the P4 proposal is being left it as a vendor extension. So that's the top level. And I just want to do a quick recap of the technology itself, because that will come into discussion. Uh, so quickly speaking, the way INT is deployed and looks like in a given deployment is that it is enabled on set of nodes or on a zone. Within that zone, there are nodes which work as initiator nodes. That is where the transition of the traffic from the native traffic to uh, traffic inserted with metadata happens, and these nodes are typically sitting at the edge of the zone, and they're called as initiator. And there are nodes within the zone which pretty much receives the traffic with metadata inserted and insert some more metadata of that node itself. They are called as transit nodes. And the last node, which is the terminating node or egress node, used interchangeably, is the one which is responsible for doing strip and forward, meaning it's going to take out all the metadata and extra information which is inserted in the packet, recreate the original packet, and forward it. And besides that, it may choose to send additional reports. And that additional report can also be sent by the intermediate nodes. As you might have heard, Huawei had a proposal of the postcards where intermediate nodes can send the reports too. So just keep that in mind. So that's how a typical deployment looks like. On the ingress nodes, the provisioning of enabling the traffic is done based on the ingress ports or ingress flows on a port. So that's how the configuration is done. And it's very critical to understand. Um, on the transit, there is only configuration is that this node is expecting uh, expecting traffic with metadata. That's pretty much the only configuration. And then there is some additional configuration that what device ID you want to program and things like that. And on the terminating node, we want to qualify that which ports on that node are the one on which if you receive traffic with metadata, the node has to do strip and forward and some other actions, right? So that's how the enablement of the feature is done on the various nodes. Okay. So before I go, anything, Mickey, you would like to add on this?
That's fine as a summary.
Okay. Any other questions, folks, if you have? Or you think something was not right or was missed? Okay, wonderful. So, so with this background, I'm going to go on the, again, I'm still keeping it high level. What is the initial, the committed code, which is there? What is the proposal at a very, very high level? And then instead of going in the code, I'm going to try to go in the differences which Mickey and I talk about, and then I'll hand it over to Mickey. I'm just trying to find out the right page. There it is. So if you see in the current TAM proposal, the idea is that TAM is a single object, and that object contains one or more telemetry objects and event objects. And telemetry and event objects is the references of various other objects, includes events and ports. And the thing which is not showing here is the what kind of report, what kind of collector, what kind of transport, and both may be referring to separate or common objects. And this one single or one or more global TAM object has a bind point which is attached to a different ports or different objects within the switch. And then the side driver is responsible for teasing apart the telemetry object, event object, and various other attributes from the TAM object and do the appropriate port configuration or any other bind point which is attached on. Right? So that's a workflow. Now, what I have done as a first step, so there are some principles with which in the TAM proposal we are following. That anything which we refer to the telemetry event or INT is contained within the TAM object. There is a one unified object, which is a TAM object. And then the bind point is also done based on the one unified object. And the idea, the reason why that is done that way is the proliferation of various other entities within the SAI subsystem. So we don't want to have a proliferation of various objects independently. So this works as a single container, and then there is a single container bind point. So the implementation of the driver becomes very, very easy in that case. So that's the philosophy. With that philosophy, what I have done, I have created another object, which is the INT object, and there can be one or more INT objects. And this INT object is contained within the TAM object. And TAM object now may contain a telemetry object, event object, and now the INT object. The INT object itself is a container for INT attributes and other various containers. The other containers is the report collector, and you will see that I have just referenced them as a union, but their applicability is node specific. Like report and collector is applicable predominantly to the terminating node and sometimes to the transit node, but predominantly terminating node or egress node. Sampler object, which does the sampling of the flows, either on a flow basis or on a port basis, is essentially applicable only to the initiator node. Same thing is the definition of the flow group, which is essentially saying that what are the set of flows which need to be monitored or need to be inserted with the metadata. That definition is also mostly on the ingress node or the initiator node, right? Right now, I have captured all these objects as a union, and in the attribute also they sit as a union. It is based on the node type, which we'll see in the INT object. Based on the node type, we do the segregation that uh, which object need to be picked and applied. So that's a very high level view. In this case, again, I'll just do a repeat. There are flow objects, sampler object, which is existing SAI object. It's not a new object which is created. Flow object is created new. Report and collector, along with the attribute, they have a reference and they sit under the INT object. INT object can be one or more. They sit under the TAM object. And then the TAM object is the one which always have a binding to the actual entity within the switch. And the SAI driver always operates on TAM object. Okay. Before I would like to just quickly do pass over the attributes just to make this conversation complete. Any questions you have before I go there? This is critical for discussion which we are going to have, the understanding. Okay, I assume that there is no I assume that there is no questions, so I'll quickly go over the. Is the screen visible or the font is too small?
It's okay. We can see it.
All right. So let me quickly go over the attributes, and then I will open the flow. So the flow object, as we talked about in the diagram, right now is defined as the flow type, or this is essentially can be thought as a flow group. V4, V6, MPLS, and tunnel. Right now, we are going to start with the support for only V4 and followed by V6. The flow attributes are limited to 5 tuple with VXLAN as the inner VXLAN with V4 IP as the inner payload. That's what it's limited to. So this is just the definition of the tuples of the flow. Okay. Now, remember I talked about the node types. The node types, there can be 3 types, which is initiator, transit, and terminator. And then finally, we have the INT type. As I earlier talked that we are tracking IAM, IFA version 1.0, 2.0, and the extension. These are the INT types we are working on. And then finally, the INT attributes. Right? So it's fairly a well-contained set of attributes. It's not too much to worry about. So in this case, we have trace type. What is the trace type? Trace type, and if you see, there are various things which are conditional here. So trace type, pro marker. This may change because for vendor extension also this may be applicable. I know for sure that Barefoot's implementation also uses the pro marker, so we have to change this, but this is just a first step. Probe 2, in the IFA 2.0, you have a clone mode and an inline mode, meaning you can create a copy of the traffic and operate on it, or you can do the insertion of metadata in the live traffic, and that's done for various reasons. What kind of protocol value we are going to use? What is the trace vector, action vector? What is the node type? As I said, so going back, so INT object also contains node type. This is the flow group which we created. Right? So this is the definition of the flow group. These are the values which go in the INT headers. So what is the hop count? What is the max length? And then this is the sampling. Right. So right now, if you see, sampler is attached to the INT object, which is attached to the TAM object. And typically, the TAM object is attached to a port like that. Okay. So that's pretty much it. So that's the attributes. There is one attribute which is missing, which is the device ID. That is the identifier which is typically set for a given node in the metadata header that I have forgotten to add. That's actually sitting in my TBD list, so that I will add. So that's the very high level, quick overview of the attributes. Now I'll go over the discussion which Mickey and I had. Then I'm going to open the floor for Mickey to go in other details which she has. So one of the thoughts we had is that the TAM object, the INT object itself, right? Is it object contained in a TAM object? Mickey, feel free to correct me if you think that there's some articulation which is not correct. So one contention is that shall we keep the INT object within the TAM object? I am of the opinion that TAM object is acting as a single unified object, and that's the philosophy we started with, and we should keep that, right? So that is one contention we have, and I would like to have a consensus on that. The other contention is that the flow object which we created here should actually be an ACL object, because essentially, if you look at the flow group will have a notion of wildcarding into the tuples. You may wildcard any field in there, and if you start wildcarding, then essentially they do look like ACLs. Okay, so we can very well have an ACL definition, which is defining a set of flows, and the ACL definition itself says the action is type INT, and the reference could be to an INT object, right? So either INT object contains the filter object, or filter object points to the INT object. Both can work, and we have to figure it out what is the right way to do. That is the other point of contention. And then as an alternate to INT object sitting under the TAM object, and TAM object is the one which is the bind point, the third proposal is that can we take the ACL and use directly itself as a bind point, which is essentially what DTEL is using currently, where everything is contained within the ACL, and then ACL has the reports, the collectors, and then ACL themselves are binded to the flows, because that's the only reference we have. Then there is some discussion we had about the node type, where node type right now is contained INT object, whether we strip it out or keep it under. There again, I have an opinion. So going back for the flow group using the ACL, I'm open for that discussion. I don't have a strong opinion. Whether TAM should be used as a bind point or ACLs should be used as a bind point, there I have a strong opinion. The TAM's philosophy is to use TAM object as a single unified object. Now, the node type, the initiator node type, I think there is a proposal to take it out of the INT object. That I'm not sure. We can, but I don't see a utility of it and why we should talk. It just makes it fragmented. So that's where we have quite a few differences right now. So Mickey, I'm gonna give the floor to you to articulate your differences in your language and create arguments for them. Do you want me to stop sharing so that you can share?
Yes, please.
Let me make you as Mickey, you started with your name, and then after that your name goes away. I think you're caller one. Say something, Mickey.
Yeah, I'm here.
Yeah, you're caller one. Yeah.
Okay. I don't know if I does that. It's not what I'm seeing, but that's fine.
Okay, yeah. Now you're back to Mickey again.
Okay. Okay, so it looks like I am sharing the screen. So thanks, Jay, for taking a first stab and for articulating, why you have things certain ways and starting down where our differences are. So regarding using ACL, the reason that I believe ACL should be used completely and ACL should be the bind point is that everything really happens on a per rule basis. So as was mentioned before, if you want to define flows or filters and get subsets of traffic, you're basically matching fields such as 5-tuple fields, and you're using masks and things like that. And in my mind, we already have a well thought out, fairly complete architecture for all that in SAI. And if you look at a lot of the fields that need to be driven differently for different flows, you have things like trace vectors and max hop or max length and so on. So these are values that different flows, you may want to collect different information. You may want to set a different max hop length. You may want to sample at a different rate if you happen to be doing sampling. So there are a bunch of things that need to differ, to my mind, essentially on a per rule basis. If you don't drive that from the rule and you keep a lot of those values in the TAM-INT object, then you find that you have multiple TAM-INT objects with the different combinations of trace vector, max hop, and such. And so then you would essentially have different ACLs pointing to things. But I think it's much more contained if you have one ACL which has multiple rules within it. You need a priority on the different rules. So what happens if you get conflicts where things are overlapping? So maybe my default is on a /0, I do certain things, but then on a particular /24, I want to collect more detailed information. I set the information I capture a little differently. So we need a way to resolve between different things, and that's one of the things that's missing in the flow definition right now. And then we don't have to worry about picking and choosing, which fields, which protocols, do I do tunnels, do I do inners? ACLs can handle all these things right now. And then there is a big question about bind point, that the whole structure of ACLs today does contain a bind point in the ACL itself. So should the bind point come from the ACL? Should it come from TAM? What goes on? And I feel we should use ACLs to their full extent. Any questions, discussions, opinions about ACL versus flow?
In the original proposal, I don't know, I'm not able to find out how the flow is attached, or like what is the binding for the flow. So I see the qualifiers for the flow, the 5 tuples and the VNI ID, and and certain things, but I'm not able to find out how it is bound to a port or a VLAN, those stuffs.
Oh. Did I? Yeah, I need to
Sorry,
open.
what was the question again?
No, Jay, in your first proposal, I'm not able to find how the flow attributes are defining the 5 tuples on the VNI ID, right? With how is it bound on a specific port or a VLAN that I'm not able to find in your commit?
I see. Okay, so yeah, so bind is always done of a TAM object, and the flow group definition, that what are the set of flows which are to be monitored, they are being binded to INT object. And so let's say that I say that flow group, all the flows going to destination 1.1.0/24, right? All the flows going to destination on this subnet. That's my flow group definition. And I assign that what INT object this flow group will go to. And this INT object goes and sit under the TAM object. Then TAM object will get binded to a port. And the side driver will take walk the hierarchy, get the flow definition, and then enable that through whatever means that device supports. So some device will support enablement through the ACL rules. There are some devices which support the same function through the hash table. And I'm talking like even in my case, in Broadcom case, the devices, we have exact match table, we have IFP. Actually, IFP is a very constrained resource. Most of the time, flows don't go in the IFP. We put it into exact match table. And exact match table does support wildcarding. So, so that they go through the appropriate API underneath in the side for the TAM object. And that was one of the reasons why I was reluctant to put under the ACL everything, because not everything is attached in the hardware to ACL. But Mickey had a point, like in detail, they have taken the ACL driver and they call arbitrary APIs for the barefoot chip, which truly are not the ACL APIs. They're not the ACL tables. So his argument was that, on the top, I'm just using ACL framework, but underneath I can call whatever I want, right? That's fair, right? So, but the way it's going to work, again, coming back, the TAM object side driver will look at the INT object. From there, it will get the flow definition, and those flow definition it will use to either call the ACL APIs or any other APIs. Does that make sense, Sadish?
No, but how do we qualify of a specific VLAN if I want to define the flow, right? So that is possible under the ACL constructs.
Right.
But the flow attribute also should be like including that, right?
Right. So right now it is very bare bones. It's not. It's defined only for V4 packets. Yeah.
Right. So in Jay's proposal, and I just highlighted where this is in the TAM INT object, there's a list of flows, which is essentially 5-tuple with mask and inner and so on. And then the alternative is basically that ACL defines all these things, and then the ACL points to an INT group. So you would take the TAM INT objects that are flow specific, and you would throw them into a TAM INT group object, and then you refer to that from the ACL. And so it's only the action that's changing. The match criteria is all defined in the ACL.
Sadish, does it make sense?
Yeah, but the only thing is like once we I mean, based on the use cases, right, the number of qualifiers to define the flow and things will be like expanding ever, right? So that is when like fitting inside the ACL model would be easier. Will be like I thought we'll already have enough attributes in the ACL model that will be able to define a flow in any granularity, right?
That is correct. Yeah.
Yeah. So.
Yeah. So that's why I was proposing to go with an ACL approach. So I guess there's a question whether we can converge on an ACL approach, and then if we were to decide that way, then we have to decide, are we taking all of ACL? Where's the bind point? That becomes the next part of the discussion.
So the first point, what Mickey is saying, that if we agree on the flow group definition actually coming through the ACL, then in the current proposal, the flow of the objects is coming through the TAM object bind point. And his question is that can we take the ACL itself as an independent object and then basically create a parallel infrastructure that will have no intersection with TAM. That's.
I mean, it doesn't. If you use ACL as a bind point, then it doesn't hook into the same hierarchy that Jay had defined, where everything sits under a TAM object that's bound to something, typically a port. But I think there's more options too, right?
So essentially, that becomes a separate infrastructure completely.
Well, you still have objects and attributes defined in TAM, but they are not connected to the rest of the TAM hierarchy.
The flow object is currently like that, right? Even in the Jai's proposal, the flow object is kind of related only to the INT.
Yeah, but it's referred to from the TAM INT object, which sits under a TAM object, which sits under some bind point. So a lot of where we couldn't come to full agreement is, Jay feels that everything should come under the same hierarchy, whereas I feel that things have, as you look at the different content, they naturally fall into different categories, and not all of them necessarily fit within one TAM hierarchy.
So one way to do is like what Mickey is saying. We take the ACL. ACL already has a bind point. We just throw in the INT constructs in that hierarchy, right? So there are some constructs. Right now it is a little bit not generalized. We clean it up, we generalize it, and that becomes independent hierarchy with ACL as a bind point. Okay. And the other proposal is that we take the ACL. If Mickey can go to the other screen. Yeah. The flow screen, flow group, the TAM screen. Yeah, here. We take the ACL itself, and here, think of it, there's actually ACL object sitting here, which gives you the complete, as you were saying, Satish, all the various kind of flows, and which is enumerable because ACL is rich in the enumeration. We put the ACL object list here, and then rest of the hierarchy and the attributes sit under the TAM. So those are the two approaches we are talking about.
So I'm not sure what it means to put the ACL here. Would you be pointing to an ACL entry or an ACL?
I'm not clear as well, Mickey. I have not thought about it. There are two ways we can look at it. We can either point the ACL action to a INT object.
Yeah, that was my preference. And then what's the alternative?
Right. And the other thing is, and I don't know if that's the better way to do it, the ACL object itself, if we can reference the ACL object into the INT object. So one is INT object, ACL pointing to INT object, other is INT object including the ACL object or pointing to ACL object.
So in my mind, when you have different flows, they might want to do different trace vectors and things like that. How would you capture that if not through the action, or it's unclear to me how the binding works the other way?
In my view, when you make the ACL point to the INT TAM, that is when the SAI driver can know that this need not be installed in the regular ACL TCAM, right? It is like has to be specially handled in case, as you say, if it goes into the exact match cam or some exact match table. So we can take that decision if we make the ACL construct or ACL object point to the ANT TAM, right? We can
So
take that
Satish,
decision.
question for you there. So in the side driver, when we invoke the API with the TAM object, you will be able to walk the list and get to the INT object. But how will you know what all ACL objects are pointing to that INT object? Do you have a mapping?
No, I was thinking when the binding will happen in the ACL object itself, when the ACL object will be pointing in the action, as you were pointing that approach as well, right? In the ACL object, the action will point to the TAM INT object.
I see. I see.
So
Okay.
in
And
that case, we can identify it in the implementation and take the necessary approach.
I see. So I see what you're saying. Okay, let me try to understand. So in that case, ACL object is passed to the side driver, and in that case, the action will point to the INT object, and INT object will have the current attributes just the way they are defined, including the node type, the report, the collector, whatever it wants to do.
Mm-hmm.
Okay, and then the inclusion of INT object into TAM object is moot at that point. And that goes back to, I believe, what Mickey was trying to say a little bit, not all of it, but part of that statement was that. Then we really don't need the binding of INT object to TAM object. I mean, that's a useless binding then.
Well, I think there's other things we have to discuss regarding binding of INT to TAM, but the point is that in terms of initiator, if it's coming from ACL pointing to TAM things, then that is outside the TAM hierarchy and the TAM bind point.
And I see that you have the collector math functions embedded inside the INT TAM anyway.
Right.
So it's kind of
Yeah, I mean, that's another discussion that we need to get to, is whether the TAM INT object that Jay proposed is one object or several, and where do the pieces belong. So we'll have that discussion as soon as we finish this ACL discussion. Or we can bounce back and forth if you prefer.
Oh, okay. So can we call some, in the interest of time, can we call some consensus? I want to make progress. So do we have a consensus on passing the ACL with ACL action as a reference to the INT object? Just one statement. Nikki, are you good with that?
So what INT object it refers to, I think we still have to discuss, but some object in INT, yes, I agree.
So let's go with currently whatever the INT object is defined in its entirety.
I think that's the next discussion we need to have, is the INT object one thing or not? To my mind, there's 4 different types of things in there, and we have to discuss that.
Okay, Satish, how about you?
Yeah, the other aspect is to see if the ACL, right? The ACL is really attached to only a specific port, or because in the current model, the ACL can be attached to different bind points, right? Port, switch port, VLAN, RIF, things like that. So how does that play with this flow definition for INT? That I'm not clear right now. Because I don't know really the use case for defining the flow in the INT. So will it really be useful to define the flow at a specific port or a VLAN so then we can define that it will be relevant for that port or the VLAN, provided we can also qualify that in the underlying hardware table. So I mean that part I'm just bringing it up. Otherwise, I am okay at a high level to have this kind of model.
So Sadish, you pointed to an interesting point, and that's where I was starting from. That in any there are few things you have to realize from a deployment point of view. That the deployment is going to be, it has to be less complicated to be usable. This technology itself is fairly complicated, right? So there is not going to be very wild usage or pervasive usage on a given switch. Meaning, what I mean by that, and this I'm talking from a real deployment, right? We don't have the uh, folks from Alibaba I would have preferred. So this is actually deployed. In that case, typically what they do, they use a very coarse granularity of a flow definition. So there is a high priority flow which they want to monitor all the time. They are static flows. They know ahead and they install it as fully qualified static flows. There are dynamic flows which are learned. Actual flow learning happens, and they, based on some policy, those flows actually get enabled for monitoring. Now, where those flows are learned, which import they're coming from, that's irrelevant in that case. So the only thing relevant is the scale that they will only, and that's limited by the hardware scale, only certain number of flows, right? So in that case, the classification of the flow is done on a very high level. UDP flows, TCP flows, these are the flow groups. TCP, UDP, VXLAN, Rocky flows, they are separated, although they are UDP flows. And then there is a proprietary VXLAN. Okay, within that group, which is the IFP match, then a certain number of flows are enabled, which is the exact match. Okay, so that's how the enablement is done. Beyond that, there is not much qualifiers used for flow.
Okay.
Yeah,
Right?
but
And that's the way.
that's an example of how people can use things. To my mind, yes, ACLs is a more complex superset, but you don't have to implement every knob and every little thing in ACLs. ACLs allows us to have the superset definition that we don't have to keep extending, we don't have to keep modifying, so on. But you can implement whatever subset applies for this type of functionality. And
that is fair.
People are using the ACL construct.
Yes, maybe that's fair. I mean, yeah, I agree with you, right? I mean, it's a superset, and we may choose to use only subset of the functionality, right? I'm just telling you what the actual deployment is going to look like typically, and we have to be a little bit careful. We as an engineer tend to solve every possible scenarios, which sometimes create our solution more complicated. The other part which I want to point out, and which is that in a typical deployment, you will not have a trace vectors on a per flow basis. They are globally configured on a node. It's very hard for a pipeline to support different trace vectors on a per flow basis. Can you support it? Yes, it's expensive. Right?
I don't see any problem with that. I mean, and to my mind, the granularity of flow and how many flow entries you have is completely up to the customer, right? So yeah, we're not going to be supporting. I don't think many implementations are doing tens of thousands of flows, but if you want to define 5 flows and have like UDP and TCP and so on, you can do that.
So typically, in this case, the way I approach is I put a constraint. I say my constraint is that the trace vectors are node behavior. They are globally applicable to all the flows on a node. And is that okay for the deployment? So far, I have not come across anybody who said no. On a given node, give me actually nobody cares about trace vectors, to be honest, right? So, and given that we have a namespace now, even in IAM, then you can have a different namespace which gives you a more compact metadata definition. So trace vector is more of a theoretical discussion. Truly speaking, it's hard to do in hardware. Typically, I mean, not hard, it's expensive to do it in hardware. So we don't even bother about it. Trace vector typically are all set to 1 with a namespace, which
I don't see it as expensive, but fine. We don't need to focus on trace
Yeah, we don't
factor.
need to focus on that. That's just observation.
You
Yeah.
could go to things like sample rate, which definitely would need to vary on a per flow basis if you're doing sampling. I mean, not that it's different for every flow, but some flows will have different sampling percentage than others.
That is correct. Yes. Yeah. But again, there will not be 100 of samplers. There is already a
Sure.
limitation of the samplers which a given chip will support, right?
Yeah,
So,
a handful is fine for most deployments, sure.
right. Exactly. Yeah. Typically, you're right. There will not be more than 4 at the most, right? So I'm just making points that though we can engineer a design which is, encompassing all the possible scenarios, does it make sense? So we have to be a little bit careful on that. So the assumptions I'm making here: trace vectors typically globally defined, flow group definition very well contained. The qualifiers for the flow group are not going to be too many, at least for now. And then samplers also will be typically a small number.
Okay.
Go ahead, Vicky.
But whether it's max hop count or sample or trace vector or so on, if these things were to reside in some sort of TAM-INT object, then this is why I think that the ACL action needs to refer to that object, because different rules could then refer to different TAM-INTs with different values of those things. Not that you'll have 1,000 of them. You may only have, a small handful, but different rules in the ACL would need to possibly refer to different such objects.
I do see one advantage if if the ACL is pointing action to the INT object, then my INT object is essentially an attribute set, right? Which says that what is the trace vector, what is the action vector.
Yeah.
Then if it is per node definition, all those attributes are globally a single definition, then I can have only single INT object which is being pointed by the ACL, right? If there are multiple trace vectors, in fact, if we really want to degenerate the use case, every flow has a different probe markers. I'm just picking an example, right? Then you can have multiple INT objects with different probe definition, different trace vector definitions, and then depending on the flow, ACL flows, you can have an ACL entry pointing to that INT object. In fact, it works either way we want, and it works pretty elegantly.
Yeah, so that kind of leads into my other big issue is if we look at everything that's in the TAM-INT object that Jay proposed, to my mind, there are actually 4 different categories of attributes in there. And the question is whether they belong in one object or different objects and how those objects should be organized. So one is things like the IOM trace type or IFA trace vector, and max hop count. These are things that, to my mind, flows could refer to different collections of such attributes. Then a second grouping, and there's a question whether it belongs together or not. There are things like these probe markers and protocol. So what protocol is here is in the IFA proposal, you set the IP protocol value to some value that indicates that IFA is in the packet next. And then within the IFA header, you have another protocol field that tells you what the actual L4 protocol is. So things like probe marker and protocol are the things that you put into the packets that identify presence of INT metadata within the packet. So the question, so one thing that I wonder is, do you really want to do that on a per flow or trace vector max hop type of basis, or is that more of a global thing that you set once and it just applies to everything? This is how I identify presence of INT metadata in my packets.
So Vicky, I thought we just talked about that. So there are a few inaccuracies here. these are not the things which are set. Oh, no, actually, that's correct. So pro markers and even the IAM header, the IAM trace vector, if we go up a little bit,
Yeah.
right? So IAM trace type, this IAM trace type, all these fields are set by the initiator node because it's the one which is inserting the IAM header or the
Yeah.
data header, right?
Yes, so they're all done by the initiator, but my question is about the granularity that to me, things like trace type and max top in sampling may vary on different flows, but I wonder, why would you need to specify probe marker or proto on a flow basis or group basis that flow points to or ACL points to? Wouldn't you want the same values for all of your traffic?
Right. So, but that's what we just talked about. You can create a single INC object which has trace type, probe markers, protocol, whatever attribute, and then all the ACL entries can point to the single INT object.
Yeah, but so my suggestion is that things like trace type and max length and sampling are things that you could point to from an ACL, but why would you want to point from an ACL to things like probe marker and proto? Shouldn't that just be set once and apply for everything?
I can use the same argument, right? You may have some flows which are using certain probe markers and certain other flows using different probe markers.
And I see no advantage to that. And, this
I mean,
is how you distinguish your
not
metadata traffic from your non-metadata traffic. Why would you need multiple such values?
It depends, right? Where the traffic is coming from. Let's say domain 1 chose to use one set, domain 2. I mean, I'm just playing your argument.
Yeah. So let me chime in. We are at 9 o'clock. The meeting after us will start very soon. I think this is a good time to pause here and to take it offline to think about it and reason again. So you are encouraged to have offline discussions. Thanks Jay and Mickey for driving this. Let's take some time to think about it and resume this in 2 weeks.
Okay, thanks, Ed.
Yeah, and also calling out if your company hasn't signed off on the TAM v2 design doc and SciTAM.edge. That is the previous version that we would like to release in 1.4. Please take time, take a look, and